Today we are starting Unit 4 on quadrilaterals, and our first lesson is the properties of parallelograms. Alright, so here's a couple of definitions. A four-sided figure is called a quadrilateral, quad meaning four. And a quadrilateral with both pairs of opposite sides parallel is called a parallelogram, and that's what we're talking about today. And you can see on the picture that we've got the top and the bottom are parallel. You can see that with the little arrows, and the left side and the right side are also parallel. So those arrows indicate that the lines are parallel. Are all parallelograms quadrilaterals? Are all quadrilaterals parallelograms? Well, any parallelogram that I can draw where the opposite sides are parallel has to have four sides. So yes, all parallelograms are quadrilaterals. Are all quadrilaterals parallelograms? Well, this quadrilateral is not a parallelogram. This quadrilateral is not a parallelogram because this side and this side are not marked parallel. They have to have the little arrows on there to show you that they're parallel. And same thing here, this side and this side are not marked parallel because they don't have the arrows on them. So that would not be a parallelogram, but it is a quadrilateral. Or I could draw something like this. None of those sides are parallel, and yes, that is a quadrilateral. So are all quadrilaterals parallelograms? We've just shown that the answer to that is no. Do not assume lines are parallel. Make sure they have the arrows on there to indicate that they're parallel. All right, here is a theorem about parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent. And you can see on the picture there that side QP is congruent to side RS. Those are opposite sides. And also side QR is congruent to side PS. Those are opposite sides as well. So both sets of opposite sides are congruent. That makes it a parallelogram. If a quadrilateral is a parallelogram, then opposite angles are congruent. So the opposite angles are the angles that are across from each other, like so. So angle P has the same marking on it as angle R. So those angles are congruent. And angle Q and angle S are marked the same. So those are also opposite angles, and they are marked congruent. So if a quadrilateral is a parallelogram, then its opposite angles must be congruent. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Consecutive angles are angles like these two or these two that are next to each other. So supplementary means that they add up to be 180. So the measure of angle P plus the measure of angle S is equal to 180, and the measure of angle R plus the measure of angle S is equal to 180 as well. The measure of angle R plus the measure of angle Q is 180, and the measure of angle Q plus the measure of angle P is 180. Any consecutive angles like these two and these two, Q and P, are supplementary in a parallelogram. All right, then the last theorem about parallelograms. If a quadrilateral is a parallelogram, then its diagonals bisect each other. And bisect means cut in half. So one diagonal cuts the other in half, and vice versa. And from the markings in the picture, you can see that QR is congruent, I'm sorry, not QR, QM is congruent to MS, and PM is congruent to MR. Because the diagonals bisect each other, those segments are congruent, and we also know that M is the midpoint of PR, and it's also the midpoint of QS. All right, so now we're going to do some examples. So FHGJ is a parallelogram. Find the two unknown lengths. I'll give you a minute to write down your answer. Okay, because opposite sides in a parallelogram are congruent, JG has to be 5 because FH is 5. And because diagonals bisect each other, JK has to be 3 because KH is 3. And if they asked us for JH, JH would be equal to 6 because it's 3 plus 3. Example 2, PQRS is a parallelogram. Find the angle measures. So find the measure of angle R and the measure of angle Q. I'll give you a minute to work on that. So remember that there's two theorems about the angles in a parallelogram. One is that opposite angles are congruent. The other is that consecutive angles are supplementary. Congruent means they're exactly the same. Supplementary means they add up to be 180. So if the measure of angle P is 65, then so is the measure of angle R. It would be 65 degrees because opposite angles in a parallelogram are congruent. And then the measure of angle Q would be 180 minus 65, which would be 115 degrees, because consecutive angles in a parallelogram are supplementary. Now the measure of angle S would also be 115 degrees. Okay, example 3. ABCD is a parallelogram. Write an equation and solve for x. Okay, in order to do this, we use our theorem that says that consecutive angles in a parallelogram are supplementary because these are consecutive angles. They're next to each other rather than across from each other. So write an equation and solve for x. So the equation would be 3x plus 120 equals 180. Because they're supplementary, they have to add up to be 180. Subtract the 120 from the 180. 3x is equal to 60. X is equal to 20. Okay, last one. Here we have to remember what we learned in pre-algebra and algebra 1 about substitution and elimination. So we're going to use our theorem that says the diagonals of a parallelogram bisect each other. We do need to know that this is a parallelogram, so I should add that. That's very important. The figure is a parallelogram. Never assume that. You have to be told that or given that. So that means that 3x is equal to y plus 7 because this segment that I'm highlighting in yellow is equal to that segment that I'm highlighting in yellow, and y is equal to x plus 3 because this segment is equal to that segment. So we have a couple of options. One option is to solve both equations for y. So this top one, we could take this 7 and move it to the other side. So that would be 3x minus 7 equals y. So now we have this equation that's equal to y and this equation that's equal to y. So if they're both equal to y, then they have to be equal to each other. So 3x minus 7 equals x plus 3. Solve for x, subtract the x from both sides. So 3x minus x is 2x. Add the 7 to both sides. 7 plus 3 is 10. And so x is 5. It says find the value of the variables. That means both of them. So x is 5, so I'm going to plug that x in to this equation here. Y equals x plus 3, so y equals 5 plus 3. So that means that y equals 8. So I have x equals 5 and y equals 8. Let's check our answer and see if that works. So if x is 5, then this segment is 15. If y is 8, then this segment is also 15. That works. And if y is 8, this segment is 8. And if x is 5, 5 plus 3 is also 8. So that works as well.